This probe is going to Saturn, but you may ask, where are the rings? Haha, fooled you. That was actually Venus. The probe in question is Cassini, the first spacecraft to orbit Saturn. With all of its fancy instruments, it weighed 5,712 kilograms at launch. There was no way that rockets made by humans could take it to its final destination. It was just too heavy. So mission designers programmed a multi-gravity assist slingshot trajectory. How does it work? When a spacecraft gets close to a planet, the planet's gravity throws it in a different direction. From the planet's point of view, it is leaving as fast as it came in, but from the sun's point of view, it has either gained or lost velocity. Do this enough times and you can get anywhere in the solar system. The Brainiacs prescribed to Cassini 2 flybys at Venus, 1 at Earth and 1 at Jupiter. Cassini launched in October 1997, being aimed at Venus. It arrived there in late April of 1998. At that point, its velocity with respect to Venus was 6 kilometers per second. We used patch conics to figure this one out. At periapsis, Cassini was 284 kilometers off the surface of Venus. We plug that into the turn angle equation and get 71 degrees. A cross product of the position and velocity vector at our periapsis gets us h, the momentum vector. We plug this into the Rodriguez rotation formula to calculate exactly how Venus turns our velocity vector. As expected, the magnitude of our v infinity was unchanged, but the direction is. Adding Venus's velocity vector to our own, Cassini's speed around the sun rose by 3.4 kilometers per second, but its velocity vector changed by over 9 kilometers per second because Venus also bent its direction dramatically. But to see Venus again, it had to start its engines in December 1998 and execute a deep space maneuver with a 450 meter per second magnitude to lower its periapsis and line it up for another flyby a couple of months later. This was crucial to ensure it got to its destination, as without the burn, Cassini would be stuck in this heliocentric orbit. Approaching Venus again, it had a higher velocity with respect to the planet, v infinity 9.4 kilometers per second. Its altitude at periapsis this time around was 623 kilometers farther away. The turn angle was 41 degrees. But the change in heliocentric speed was actually higher than the first flyby because it was moving much faster than Venus to begin with. Once again, v infinity with respect to Venus does not change. Next step was a flyby of Earth in August of 1999. At this point, it was moving at a whopping 16 kilometers per second with respect to the planet. Its closest approach was 1,170 kilometers away. This corresponds to a turn angle of just 19.2 degrees. This number has been dropping because our periapses have been getting farther away from the planets and our relative velocities have been increasing as we do it. Earth's slingshot still provided the craft with a heliocentric speed boost of 3.4 kilometers per second, delivering enough energy to its next step, which was actually not Saturn. In order to reach Saturn, the craft needed a small boost from Jupiter as well. Jupiter is over 300 times as massive as either Earth or Venus, which means it can substantially bend the trajectory even from farther away. But for this mission, Cassini only needed a light shove. Cassini's closest approach to Jupiter in late December 2000 was almost 10 million kilometers away from the gas giant, yet it still got turned 11.3 degrees with a minor boost, 1 kilometer per second, in heliocentric delta V to line it up with Saturn. This last leg has been sped up by a factor of 3 due to Kepler's second law. The craft pulled up to the Saturnian system in July 2004. At periapsis, about 20,000 kilometers from Saturn, it executed another 626 meter per second burn to get into orbit. And after burning for about 96 minutes, Cassini was in orbit around Saturn. Over the next few years, Cassini continued to use repeated gravity assists from Saturn's moons, most notably Titan, saving over 90 kilometers per second in delta V, roughly 37 times what could have been accomplished by propellant.